So how many of you guys know about Supermicro? One. So if I were to ask you, what do we do? Can you explain what we do? So basically, we are the guys who do build everything in the background, probably build things that you do not even see. That is probably because, how many of you guys walk down to the data center or your labs? Right? Great, 2 of you. And the rest of the guys probably are coding from a Starbucks, drinking their frappe, right? So that is what we do. We do it in the background, which is build the compute, network and storage, the infrastructure for you, so that you can start coding from wherever you are in the patio or from your Starbucks cafe, right? A little bit of history on Supermicro. Publicly traded company, 3 billion plus run rate, headquartered in San Jose, with the regional headquarters in Taipei, Taiwan, as well as in Netherlands, right? And rapidly growing with a lot of engineering resources being put back into growing the company. That way you get the best in technology and innovation. So if you were to look at Supermicro, the way we started was way back in 1993, designing the motherboards. As you all know, for a good system, a design of the motherboard is very, very essential. And that's how it started, 1993. Fast forward 2018. Today, we are into complete end-to-end systems with our partners, say, Canonical, Red Hat, as well as SUSE, right, if you're looking at the OpenStack. Now, to make it interesting for you, you already made it very clear. You never go down to your lab, you never go down to your data center to see what is happening. So I will try to spin it in a different way so that it is more interesting for you. When we talk to our customers, you guys, you have always been saying, with the digital age, every year, year over year, your requirements for the compute is going up by 30 to 40%, right? The storage is the same case. So there is a lot of demand for you guys to stretch your already thin resources, because your IT budget is not going up by 30 to 40% every year. In fact, it is shrinking. So there is a demand to do more with less. So to go back in history, right, 8 to 10 years ago, we had the blade form factor because that provided the density. But then again, when you looked at it, there were certain shortfalls of the blade because they were sharing a common backplane. So whenever it shares a common backplane, you slam it in, there is a bent pin, and then it doesn't work properly. Then you have to look at the bent pins and see which one is bent, straighten it out to make it work. A lot of hassle. That's where Supermicro kind of, was looking at the problem and trying to think how to solve this. So anytime we have a problem, the best thing is to look back into our history to find a solution. Usually that's the case. So the solution in our case was pretty much simple. Break it down, make it more modular. That's when we worked with Intel 8 years ago on the twin technology. What it really means is it brings the density of what you guys see in a blade in a form factor that is more convenient, takes less of your real estate, and more importantly, it shares the chassis and the power supplies, but it doesn't have the backplane. So many of you probably saw this one, the 2U4 node, right? When you do the calculations, it's a maximum, it provides the best performance per dollar per square foot because of the 2U form factor. It doesn't take a whole lot of real estate, and it provides the best ROI, right? So that was the 2U4 node. This was the one which kind of created a new category called hyperconvergence. A lot of players went on to win big in this segment, standing on the shoulders of Supermicro. So that is one thing we kind of did really well. So fast forward, 2018, this is the new one that we released. It's called the Big Twin. Same 2U4 node form factor. That means we have not increased the real estate space, right? It takes up the same real estate what it was taking 6 years ago. But what this one does is it provides more memory for you. 3 terabytes of memory in a 2U form factor. 4 nodes, 2U form factor, that is 12 terabytes of memory. What it really means is you can bring on the most memory taxing software application in memory compute application, still run it with the NVMe in there in the storage. Or you can use the same thing to kind of use it for your tier 2, tier 3 by toning down on the amount of memory, as well as going with a hybrid structure where you have the NVMe or SSD for a cache layer and the spinning disk for the capacity tier, right? Or you can do it in the archive, going with all spinning disks. So it's the same form factor that you can deploy in a tier 1 mission critical application using all NVMe, more memory. Or you can kind of bring it down and use it in a tier 2 or a tier 3 or disaster recovery applications. So all is good, right? We solved the problem. Modular design, 2U 4 node, we have a similar thing in a 4U 4 nodes and 4U 8 node, right? It only shares the power supplies. It doesn't share any of the backplane, so we remove that problem. But then again, how many times the application demand is going up, the applications are becoming more hungry. So what it really means is you want to be able to do more with less. And every 2 years, you come up with a new processor technology. But how many times do you refresh your infrastructure every 2 years? Sometimes you wait a little bit longer. So what it really means is you're not able to provide enough of horsepower to your applications. So still there is a problem, right? We haven't solved everything. So how do you tackle that one? The way you look at it is, when you look at the motherboard, there is a CPU, there is a DRAM, and then there is I/O. You can kind of separate your CPU and DRAM, that way it's a module, it's more modular in design, that way you can plug in and plug out depending upon the processor technology. That means you're decoupling your CPU DRAM from the rest of the system, that way you can scale independently, refresh independently. So that's what we have been doing, working together with Intel. This is something which is in deployment today. So what really it means is you're decoupling your CPU and DRAM from the rest of the system. That way when a new processor technology comes in the 18 months or 24 months, all you need to do is replace that particular module. Because when you look at it, when you were kind of refreshing your systems every 3 years or so, just for getting the more number of cores in a CPU technology, you were kind of still throwing away some of the other components which were still not to the end of the life, right? For example, the power cables, the power supplies, the I/O, the SSD, or the NVRAM, or the spinning disk, they still have useful life. So by throwing away a complete system, by doing a rip and replace, you're still kind of contributing to the e-waste. You're just filling up the landfill. With this technology, you're kind of disaggregating it, you're separating it, which means independently you can kind of ramp up your CPU when the new technology comes in. It's more modular, it's plug-in. And if you want to change your I/O, you can kind of change it too independently. So what it really means, you're decoupling everything, you're not doing a wholesale rip and replace, rather you are doing as and when required. So that is a huge saving for many of our customers. Like in this case, it was close to 40% savings, right? And on top of it, you're trying to contribute to the Mother Earth by not filling up the landfills, which is a good thing. You are kind of being socially responsible. There is another technology that we are very closely associated with, which is the NVMe. We were the first ones to introduce NVMe 3 years ago, right? At that time, the adoption rate was very slow, but now it is pretty much more than 50% of what we sell is the NVMe. The reason being, your applications can run much faster, right? And it is much more efficient and performance intensive. On the NVMe front, what you see here is a 1U system. 1U, 1 petabyte. Can you believe it? Earlier, if you were to get a 1 petabyte capacity, you would probably require a rack full of storage drives. This one is a 1U form factor, which is a huge benefit to our customers if you're trying to use it because you're reducing the footprint. Pretty much you brought it down from one full rack to 1U. That's a whole savings in the space. And more importantly, it runs with the higher IOPS. That is a huge benefit to the applications because it can kind of accommodate more. So in this one, we have different formats, U.2, M.2, as well as a ruler, depending upon the form factor that you want. And they are available in 8 and 16 terabytes, and likely to be 32 terabytes in the future. So that gets you up to 1 petabyte. So what is it for you guys? Oftentimes you don't even go to your data center, right? So what it really means is all this technology innovation that's happening in the background, it transforms to you in a way that when you are spinning up your containers, when you're spinning up your VMs, you can be rest assured that all the infrastructure is pretty much tested and validated on these 3 different leading distributions, which is a Canonical, Red Hat, or a SUSE, depending upon which distribution you like. You can be rest assured that this will run seamlessly from day 0. And service and support is very important for any organization, right? And we have a global service and support. That way, whether you're deploying in which part of the world, pretty much there is service and support available to you. That way, if something were to go wrong, you'll be operational pretty soon again. Having said that, why Supermicro? Because when it comes to infrastructure, you have plenty of choices. Why Supermicro? The answer is very simple, which is we bring the next generation technology to you today, like you saw the 1 petabyte, or if you're looking at the disaggregated architecture. So that's a huge win, right? And the second thing is, like we talked about, it's the best performance per dollar, per watt, per square foot, because we are kind of providing the dense systems in a condensed form factor. And we are always first to the market when it comes to new technologies. Case in point, NVMe or the Xeon scalable processors. And more importantly, we do realize that your requirements are different. It's not one size fits all. So at Supermicro, pretty much anything you pick it up, we will provide customization if required. Fully configurable customization available, and it is available at rack scale. And it provides a lower TCO because of all these things. And more importantly, it gives you the peace of mind because it has been fully validated, certified to run on the different distributions that you like, which is Canonical, Red Hat, or SUSE, and available global support. This is the complete portfolio, right? And many different variations available if you go to our website. Having said that, we are right across there in the front, booth B9. Come visit us. You can see we have a 14U rack there displaying our latest compute, memory, and storage, along with our switching portfolio. With that, do you have any questions? If not, thank you guys. Have a good show. And we look forward to meeting you there at booth 9. Thank you.